Hello students, so today we begin a new chapter and we will see what the name of the chapter is slowly, but for now let us just see a sequence, or a set of a set of numbers called Fibonacci sequence. Okay, now this sequence is made by two numbers with the foundation of two numbers. Then what you do is you add these two numbers, 0 plus 1, and you get 1. Then you add the previous two numbers, that is 1 plus 1 2, then 1 plus 2 3. That is Fibonacci sequence. You keep going. Okay, 2 plus 3 5, 3 plus 5 8, 5 plus 8 13, 8 plus 13 21, 13 plus 21 34, and so on. You can keep going. So that itself, I mean, it's a good now it doesn't sound much interesting now, I do understand that, but wait till I get my calculator and take any two numbers in the sequence, okay, which are close to each other. Any two numbers close to each other, for example 3 and 2, suppose I'm taking, and let me divide 3 divided by 2 is equal to 1.5. Okay, so let me write that down, 1.5. Then take next two set of numbers. I took 2 and 3 last time, now I'll take 3 and 5. Okay, so I'll take 3 and 5, and if I'm dividing 5 divided by 3, that will be equals 1.666. So let me write that down, 1.666. I know that you don't understand why I'm doing all this now, but keep waiting and keep looking. Okay, now let me take the next two set of numbers, 5 and 8. So that I will, when I divide 8 by 5, I'll get 1.6. Then let me take the next two set of numbers, 8 and 13. 8 13, 13 divided by 8 is 1.625. Then next two set, 21 divided by 13, that will be 1.615. 34 divided by 21, that will be 1.619. And let me get more numbers here. So 21 plus 44, that is 55. 34 plus 55 is 89. 55 plus 89 is 144. Then it keeps going. It's an infinite series. It keeps going on. So anyways, let us continue taking the quotient. 34 and so 55 divided by 34, that will be 1.617. 89 divided by 55, 1.618, and 144 divided by 89, 1.617. Students, look at this, all these numbers. Do you see that it is all almost coming to 1.6 something? This is 1.5, then it goes up to 1.66, then it comes down to 1.6, then it goes up to 1.65, then it comes down to 1.615, goes up to 1.619, comes down little to 1.617, goes up a bit 1.618, comes a bit down 1.617. So do you see that this keeps going as the numbers get more and more, as you expand the numbers, Fibonacci sequence, more and more and more, you see it approach, I mean, you see that all these numbers are approximately equal to this this ratio, or this number. The name of this thing is, this is a Greek alphabet. It is called phi. Okay, it's the name of it. It's phi, the Greek alphabet, and this alphabet is used to represent the number 1.61803398875. And if you look carefully, all these numbers approximately, it approaches, or is approximately that ratio, is approximately that number. As you go to bigger numbers, it becomes more evident. Okay, so, and this is an irrational number, irrational. It will not end. It doesn't terminate anywhere, so it keeps going on. Now, this is also called the golden ratio. This number is called the golden ratio. And you would think, so why? I mean, what is the speciality of this? This is a number that we keep seeing around us. Around us. We keep seeing this number around us. For example, a sunflower. The inside of the sunflower, the spirals are based on the golden ratio. Okay, look at this video, and while the video is going on, I will keep telling you few things. These are the Fibonacci numbers, which I already showed you. And with those numbers, we are making a square, a square of 1, 1, then 1 plus 1 is 2. So that's the Fibonacci number, right? 1, 1, 0, 1, 1, 2. Of course, 0 you cannot make a square, so we are not making 0, we cannot never make a square. So then 1, 1, 2, then the next number 3. So it keeps going on, see? And then 5, you're making squares out of these numbers, then you're connecting them. You're connecting from one point. See, you can make a spiral out of these numbers, see? Out of these squares, I mean. See? And as the numbers keep going on and going on, see, you see this in the nature. You see this in nature. And okay, let's continue. So this is the way you calculate the official way how you calculate the golden ratio. Okay, so you see that here also it is called 5, and this 137.507 or that 137.5, what you see is actually the degrees. The golden ratio, when you write it in degrees, it is 137.5. Okay. So it's based on so you keep. So what is happening here? We saw the sunflower thing, right? So after start from one point, then go 137.5 degree, then throw a ball or do something, then keep spinning 137.5 degree, then keep spinning 137.5 degree, and keep spinning 137.5 degree, and then keep going that is based on the golden ratio. So you keep going, keep doing that, and look what shape you get. Okay, I think that is enough. So why did I show you all this? So that what you just saw is a sequence, and I know that I haven't told you what sequence means, but this is something that you see around you, or this is something that you look outside, you see Fibonacci sequence and you see the golden ratio around you. Let me show you one more thing, that is, you often see the Fibonacci number when you go around in the nature. For example, look at, okay, this is the official notation of it. This you don't have to care much. Now this is the lily flower, and you see that there are 3 petals. This is the Fibonacci number 1 2 3. The number of petals are 3. Now this is the buttercup flower. The number of petals are 5. 1 2 3 4 5. It is a Fibonacci number. Then cosmos. This is a flower called cosmos, and many species of this flower has 8 petals. 1 2 3 4 5 6 7 8. And asters, 13 petals, and 13 is a Fibonacci number. Spoon mum, this is an unusual species of chrysanthemum, and it has, if you count the number of petals, it has 21 petals, which is a Fibonacci number. Then this flower only has 4 petals, only has 4 petals, which is not a Fibonacci number. So it doesn't appear in all the flowers, but in many flowers it does appear. Okay, so Fibonacci sequence is numbers and golden ratio we see in many flowers, although not in all flowers. Okay, we see it in flowers and we see it in places around us. So that is why I thought, when we so this is what we are going to start today, or the chapter that we are going to start today is called sequences and series. And this is one famous, very famous sequence in the world, what you just saw, that is Fibonacci sequence. Okay, so as of now let us stop here, and in the next video we will really start the chapter sequences and series.